So, as you know, whatever may be the irrigation source, from source to the field, the water is conveyed through conveyance system. So, if the losses are more than efficiency is less, so what are the important efficiencies? We will discuss one by one. So, efficiency means what is the output per unit use of the input. So, if water is used through efficient manner, then the efficiency of the system is quite high. So, the irrigation efficiency is either the irrigation source may be the well or tube well or ponds or anything else, means from the source the water, if in the source water is available at 100 unit, so this 100 unit cannot be safely reached to the field level, means there are certain losses from the source to the supply level. Clear? So, first one is the conveyance efficiency. Conveyance efficiency means from the source to the field level, or you can say source is there and the field is there, so the water is lost from source to the field level. This is only the field gate and crop is there. Clear? There is no mean for the crop. So, if the conveyance efficiency means the quantity of water reach at field level in comparison to the water available at the source level, and the conveyance efficiency is denoted with the EC, and EC is the, or you can say the conveyance efficiency is the percentage ratio of the water reach at the field gate to the water delivered at the source level. So, it can be expressed as EC is equal to where EC is the conveyance efficiency in percent, WF is the water delivered at the field gate. Clear? Means the water received at the field gate, and WD is the water delivered from the source or water diverted from the source level. This is the source and this is the field. So, what are the important losses in the conveyance system in the irrigation channel? They can be quantified with the help of conveyance efficiency, and it is nothing but the percentage ratio of the water received at the field gate to the water delivered from the source level. When water is reached at this field gate, suppose this was the WD, this was the WF, and then ultimately water is received by the soil column, because roots are there in the soil column, and which is known as the root zone soil. Clear? So, whatever water is available, this is not utilized by the crop plants. The water is utilized which is received in the pore spaces, either in the macro means larger pores or in the micro pores. So, the second efficiency is the application efficiency. The application efficiency is the percentage ratio of the water stored in the crop root zone to the water delivered at the field gate, or it can be expressed as EA is equal to WS divided by WF, and as the efficiency is expressed in percentage, so multiply by 100. So, the application efficiency is the percentage ratio of the water stored in the crop root zone. WS is the water stored in the crop root zone. Clear? And WF is the water received at the field gate or water available at the field gate. Whatever water is stored, it is utilized by the crop plants. Ultimately, this is of utilizable water which is actually received by the or utilized by the crop plants for fulfilling their needs of the either evapotranspiration needs or the water is used in the metabolic activities. So third one is the water storage efficiency and denoted with the ES. Then storage efficiency means what is the total amount of water stored in the root zone after the irrigation to the water needed prior to the irrigation. Means what is the actual requirement for the crop and what is the received or what is actually stored in the root zone. So it is the ratio between means the water storage efficiency is the percentage ratio of the water stored in the crop root zone to the water needed prior to the irrigation. Means this is the stored water which is actually stored in the root zone, but the soil is previously dry, means before irrigation the soil was dry, so the requirement was quite high but storage is less. Clear? Means say for example if need is for 50 unit but storage is only 30 or 40 units, say for example, means storage in the root zone is lesser but requirement is or need is more. So the actual storage efficiency will be decided depending upon the textural classes. Say for example if the soil is coarser in texture or sandiness is more, then the storage efficiency is less. If clay or the fine particles are more, then storage efficiency is quite high. Then when the water is applied into the field through irrigation, then the distribution of water is not even. Means because in the surface irrigation method, for how much time the water is applied in the field, say for example if this is the soil surface, so if it is the upper reach, means water is applied in the field through surface method from this. So this is the head or this is the tail end, say for example in a field, whatever may be the method, either check basin method or border strip method is used or ridge and furrow method or anything surface method is used. So water is applying from one point to the another point. So water will travel according to the gravity, and if this is the supply channel, and you will see that because the more opportunity time is provided for this point as compared to this one, means water is applied for more duration near to the upper reach as compared to the tail end. Or you can say for example if this particular field or this particular plot is filled completely in 1 hour, say for example, so this point receive water for 1 hour, but this point receive water for say for example only 10 minutes or 15 minutes. Clear? So according to the textural classes, the saturation at this point not equal to this point, or you can say the wetting curve is like this, say for example, means the surface near to the upper reach is more wetted, or you can say up to greater depth the wetness is there as compared to the tail end. Clear? So the another efficiency is known as the water distribution efficiency. and denoted with the capital E, small d. So water distribution efficiency means if the distribution is uneven, then the wastage of water is there, or you can say the whatever actual water is utilized by the crop plant, this is not even. Clear? But if the distribution is like this, means this is known as even distribution, means whatever surface soil is wetted up to, say for example, 50 centimeter depth at the upper reach, and at the tail end also the 50 centimeter soil layer is wetted, so this is known as even distribution. But in surface method the distribution is uneven, so distribution efficiency give rise the picture of the evenness of the soil wetness within the root zone. And the distribution efficiency can be expressed as ED is equal to 1 minus Y bar divided by D bar into 100. ED is the distribution efficiency in percent, Y bar is the average numerical deviation from the mean depth of wetting, that is D bar. Mean depth means D bar, this is, and D bar is the mean depth of the wetting in the root zone. Say for example, if we take the 3 important points, and if the wetness in a field at upper reach, middle point and tail end is, say for example, 90 centimeter, 80 centimeter and 65 centimeter, say for example, means, so the D bar is simply 90 plus 80 plus 65 divided by 3. So D bar is the mean depth of the wetness. So D bar is the mean depth. Say for example, if wetness is up to this level, here the wetness is up to this level, and here wetness is up to this level. Clear? So D bar means the average of the total plot, or you can say total furrow or total border strip. Clear? So suppose there are 3 points. At one point the wetness was up to 90 centimeter depth, and at the second point the wetness was only 80, and at this end the wetness was up to 65 centimeter. So D bar is simply by the addition of these 3, or if more than 3 points are there, then addition of the number of points divided by whatever is the number of observations points. Clear? If there are 3 points only, then divided by 3, 4, 5 and so on. Then what is the Y bar? Y bar means if D bar is, say for example, 70 or whatever may be there, means what is the value of D bar, what is the Y bar. So Y bar is the deviation without considering the sign. Say for example, in first case 90 minus 70, in second case 80 minus 70, and in third case 65 minus 70, or you can say 70 minus 65. Means without considering the sign, deviation means what is the difference between mean depth and the depth of actual wetting. Then, so simply one value is there, second value is there, and third value is there, and likewise the D bar is constant, but suppose here is the 20, here is the 10, and here is the 5, say for example. So whatever the values are there, they can be divided further by 3. So then 1 minus whatever may be the value, and here the average depth of the wetting, and multiply by 100. This or distribution efficiency helps how even the wetting is there in the root zone. Means if the flooding method is adopted for irrigation purpose, then the distribution is very uneven. Means the wetting at the upper reach is goes, say for example, 1.5 meter, and at the tail end it may be only 25 or 50 centimeter. Means if even distribution is there, say for example if the furrow irrigation is adopted, then distribution is quite even as compared to the flooding. If we adopt the method, say for example sprinkler method, then the distribution is more even as compared to the surface method, say for example. So evenness will save the water so that the crop can be irrigated with equal precision. Clear? Means equally water can be distributed in whole the field and the wastage of water could be minimized. Then the another efficiency is the water use efficiency. Means the water use efficiency quantify the production level with the unit use of the water. Means say for example if the 1 unit water is applied to the crop, how much is there in the yield increment. Clear? So water use efficiency simply tells us the production, or you can say the output per unit use of the input or input in the form of water. Means if 1 unit of water is used, how much is there the yield increment. And this water use efficiency is expressed in two ways. Means one is the crop water use efficiency and another is the field water use efficiency. So the water use efficiency is simply measured at two levels. One is what is the water use efficiency for the crop and what is the water use efficiency for the or at the field level. Because the actual requirement of water for the crop is quite low, but in the field there are various losses which cannot be minimized or cannot be easily minimized by the farmer. So the crop water use efficiency can be expressed simply the where Y is the actual yield, that is grain yield or you can say economic yield, and Et is the water used in the evapotranspiration process, or it is simply the ratio of the yield to the water actually utilized by the crop plants. Sometimes because Et the evapotranspiration rates are not exactly equal to the consumptive use of water, but the consumptive use of water is the water used in the evapotranspiration process plus the certain water which is used in the metabolic processes of the crop plants. But since the water used in the metabolic activities is quite less, so sometimes this water used actually in the evapotranspiration process and water used in the ET plus metabolic needs are considered equal. But this consumptive use of water is something greater as compared to the actual ET. And what is the unit? Means the water use efficiency is expressed as either kg per hectare, centimeter or kg per hectare millimeter or kg per cubic meter. Means what is the yield and what is the total water used. And water, suppose 10 centimeter water applied through surface irrigation method, this is actually mean 10 hectare centimeter. Means 1 hectare area is ponded up to what depth? This is known as simply centimeters. Clear? So if this hectare millimeter or hectare centimeter is quantifying in cubic meter, means in volumetric term, then it can be simply quantified. And the water use efficiency of the dryland crops are quite more as compared to the irrigated crops. Say for example, the water use efficiency of rice is less, whereas the water use efficiency for wheat, for maize, for sorghum is high. Means 1 unit of water give rise to the something yield, or water use efficiency indicates the how much is the yield per unit of the water used. So if the yield is less in comparison to the water actually utilized by the crop plant, then obviously the water use efficiency is less. Say for example, if rice require more water but production level is quite static, so the water use efficiency of rice is less as compared to the other crops. Say for example, if maize is considered, then the yield level is quite equal or slightly more as compared to the rice, but the water use is quite less as compared to the rice. Say for example, if we see the sorghum crop in dryland areas, so the yield level is about 40 to 50 quintals per hectare. In case of the rice, the yield level is also 40 to 50 quintals per hectare, but the actual water requirement, you all know, in case of the rice can vary from 1000 to 2000 millimeters, say for example, or in maize only 500 to 600 millimeters only. Then the field water use efficiency is expressed as, or the field water use efficiency is the ratio of the economic yield to the water requirement of the crop. The field water use efficiency is the ratio of the crop yield, that is economic yield, to the water requirement of the crop, and water requirement will consider the water used in the evapotranspiration process plus water used in the metabolic activities coupled with the unavoidable losses, and or you can say the application losses, because certain water is lost in the water application process, and in certain cases some water is required for special needs. Say for example, in case of rice, the water is required for puddling. In case of the jute and sunham, the water is required for ratting process, and in saline conditions the water is required for leaching requirement. So this is all about the irrigation efficiencies. Then another topic is the prevention of the wastage of means if we provide the over irrigation, means what is the actual need for the crop. If we provide the excess water, then there is the wastage of water. So what are the important devices through which we can minimize this wastage, or how we can prevent the wastage of irrigation water? So irrigation water can be prevented with various means, or there are various methods for prevention or preventing the wastage of irrigation water. Say for example, land leveling. If the field is undulated, then the water is moved after fulfilling the depressions. Means if the field is not even, or if surface of the field is uneven, then the more water is required for irrigating a unit area. But if field is well leveled, say for example, in case of the leveled field, or a certain grade is there, say for example, if 0.5% slope is there or 0.25% slope is there, it means when we travel from head to tail, or from upper ridge to the tail end in a particular field, or from A point to the B point in the field, if the length is 100 meter, so if there is drop between elevation of the A and B is 50 centimeter, this is known as 0.5% slope simply. And if the length varied, then slope can be adjusted accordingly. So if slope is less, then water will run, or if field is leveled, then wastage of water is less as compared to the undulating field. Because if field has certain depressions and certain highlands are there, then if we wait for irrigating whole the field, then if the highlands are there, so the water will reach at these highlands when all the field can be flooded. Means, say for example, if one field is leveled one and another field has certain undulating topography, so when we provide the water in both the conditions, then water will spread with lesser time in whole the field in the leveled field as compared to the undulating field. So the land leveling will prevent the wastage of irrigation water. Then second option is the lining of the channels. Because water is conveyed from the source to the field with the help of the irrigation channels. So if channels are not lined, then there is various kind of losses. Say for example, percolation losses are there, seepage losses are there. So whatever water is present at the source level, this cannot be directly reached to the field level. Clear? Because there are certain kind of the losses. But if channels are lined, then the losses can be minimized, or you can say the seepage losses as well as the percolation losses can be minimized to certain extent. So the lining of channels is the another option for preventing the wastage of irrigation water. Third one is the means if we provide the more water than the requirement of the crop plant, then there is the loss of water. So avoid the over irrigation. This simply can save the certain valuable water, because if the water is applied in optimum amount, then the wastage of water can be minimized. Then another option is the adoption of proper you all know in the surface method there are various methods. So all the methods cannot be used so efficiently for applying the water. Means each and every method has their own advantages and disadvantages. So if the soil is having more sandiness, then do not go for flooding method, say for example. Clear? Because when we go to the flooding, then the infiltration and ultimately the percolation in the greater depth of the root zone takes place. So which require more of the water, which is not actually utilized by the crop plants, because the crop root zone is limited to the certain depth. But if water, or you can say if soil is porous, or you can say sandiness is more, then water will move from the surface to the deeper layers within a short time. But this water goes to the influence of the gravitational forces, and which is not actually held up within the crop root zone soil. So this will lead to the wastage of water. So the method can be adopted according to the crop need, according to the soil type, according to the climatic conditions. So, or you can say the proper method will save a ample amount of water which is otherwise goes to the waste. Then another method is the proper scheduling of the irrigation water. Scheduling means the water to the crop plant is applied on the basis of the plant characteristics, on the basis of the soil characteristics, and on the basis of the climatological characteristics. And another approach is there based on the calculations, that is irrigation interval. Means scheduling means at what time the water is applied to the crop plants. Means it is not necessary that if water is freely available, then you will provide the water for all the crops in day after tomorrow or one day after previous irrigation, or the complete submergence is there. Means this is totally the wastage of water. So proper scheduling means as and when the water is actually required to the crop plants. Say for example, if mustard crop is there, you know at what time irrigation is required for mustard crop. Say for example, either on the basis of the plant characteristics water should be provided, or on the basis of the soil condition, if soil having some cracks, or if we measure the moisture content in the soil, then if the water is at the permanent wilting point, then only the water should be provided. Or each and every crop has the certain physiological stages at which the water is required for complete their life cycle. Clear? So these are known as the critical stages for water need. So in nutshell, either water is applied on the basis of seeing the soil conditions or on the basis of the plant characteristics, either you can say the physical appearance of the plants, or by using the certain instruments. Say for example, if tensiometer is used for correlating the moisture need in the soil, so on the basis of the tensiometer we can decide that at what time water is provided to the crop plants, or we can embed the gypsum blocks in the soil, or we can adopt the neutron moisture meter, or we can adopt the TDR method, that is time domain reflectometry method. I mean there are various approaches to judge at what time water is applied. So the scheduling irrigation basically give rise the answer of the three questions. One is when to apply, means the water is applied at what time, means when to apply. Then second one is the how to apply, and third one is the how much water is to be provided. So this when can be answered on the basis of the timing of the irrigation, means either by seeing the soil condition, either by seeing the features of the plant, either on the basis of the climatological parameters. Say for example, the cumulative pan evaporation data are available in the observatories. So daily evaporation in the atmosphere will quantifying. So irrigation water upon cumulative pan evaporation reading can be calculated, which is known as IW upon CP ratio. Irrigation water, say for example in surface method, suppose 6 centimeter water is applied to the crop plants, the IW upon CP ratios are fixed for different crops and it will vary in between 0.4 to 1.0. 1.0 means the water is frequently applied. Say for example, in case of the rice, when the soil is wet, then water is again applied for next irrigation. But if ratio is 0.4 or 0.5, say for example in dryland crops, or say for example in case of the oilseed crops, or in case of the pulse crops, in which the water requirement is less, or they can require less water as compared to the cereal crops, say for example rice, maize, wheat, etc., or sugarcane. So second, how to apply means what is the appropriate method for application. Either surface method is used, or drip is adopted, or sprinkler method is used. And how much means what is the actual need of the crop plants, and it can be quantifying with the help of either net irrigation requirement or gross irrigation requirement. Net, you all know what is the difference between field capacity and permanent wilting point, and gross means then if this net can include the losses in the field. So how much means quantification, that is what is the total need of the irrigation requirement, the method of irrigation, and the time of application. Another important aspect of the irrigation water management is the drainage, or you can say agricultural drainage. So drainage is the artificial removal of the water in excess of the quantity required for the crop growth, because whatever is the water which is applied for the irrigation, if there is excess water, because you all know in the favorable conditions the 25% of the soil pores are filled with the air and 25% with the water. So if the air is less, then more water is there, and if more water is there, then it will create the certain problems. So the proper drainage is needed for optimum growth and development of the crop plants. So the drainage can be classified depending on the water table depth. Means you all know what is the water table. So if a soil has the certain depth of the water table, then on the basis of the water table depth, the drainage can be quantifying into several classes. Classification of the drainage, and classification of drainage on the basis of the water table depth. Means what is the actual fringe or what is the actual water which is available within the soil. So there are various grades or class. So there are 4 important classes. If water table at any place is deeper than 2 meter, then the soil is considered with the good drainage, and if the water table is near to the surface, or you can say less than 90 centimeter only, then the soil is considered with the poor drainage. Then the benefits of the drainage, or you can say why drainage is necessary, or you can say the necessity of the drainage. First one, drainage create the favorable conditions for growth and development of the crop plants. As you all know, the 20 to 30 or on an average 25% of the water is necessary for good growth and development. So if the proper drainage is there, means if aeration is proper, then the growth and development of the crop plants will be at optimum level, or it create the favorable conditions for growth and development. Then second one, drainage is helpful for better aeration. Means if water is more in the root zone, then suffocation will take place, or you can say the water cross the boundaries of the air, then there is poor aeration. Or if good drainage facilities are there, then the aeration is proper, because the certain microorganisms present in the soil are aerobic in nature, or the plant roots also respire. If there is deficiency of the oxygen, then the either plant root will die, or their functions will reduced, or the whatever microorganisms transform the various nutrients within the root zone soil, they can also hampered, or you can say the growth of these microorganisms can be affected in the poor aeration condition. Next one is the escape of the carbon dioxide from the root zone. Because when the root will respire and aerobic microorganisms can respire, then they will release the carbon dioxide, and when there is the exchange of the gases, so atmospheric air can replace the carbon dioxide, which ultimately will harm in the root zone soil if there is excess carbon dioxide accumulation in the root zone. Clear? So if proper aeration is there, then the accumulation of carbon dioxide will not take place, and this is beneficial for the crop roots as well as the soil microorganisms. Then escape of the harmful gases, like when reduced conditions are there, means when there is excess of the water is available, then the accumulation of methane, ethane and hydrogen sulfide will take place, so which will cause the reduction in the actual functioning of the roots as well as the microorganisms. So if the accumulation of the harmful gases are there, and the accumulation will take place when there is the excess water, because these gases can accumulate in the reduced condition, and reduced condition takes place when there is the excess of the water instead of the proper aeration. Then another is the increased activities of the aerobic microorganisms, because in the soil the microorganisms are there, and certain microorganisms will functions in the ample, or you can say the optimum supply of the aeration. Clear? So these are known as the aerobic microorganisms. So the functioning is well when there is the proper aeration, because they can help in transformation of the various nutrients. Say for example, sulfur transformation is there, nitrogen transformation is there, means the conversion of the nutrients from unavailable to the available form is mediated by the aerobic microorganisms. So the conversion takes place when there is the proper functioning of these microorganisms, and which will require the aeration. Then removal of the because when we drain the water through artificial mean, then what are the dissolved salts are there, they can be escaped or they can be removed from the field to the certain other places. So the removal of the excess salt also takes place with the help of the drainage. If in the soil the water is available, then the warming of the soil surface is done in very short time as compared to the dry soil. Particularly in the month of the winters, the warming is quicker in presence of the air as compared to the water, because water will receive the heat or trap the heat which ultimately warm in longer period of time as compared to the dry soil. Because if water is there, it will trap the heat, and whatever actual soil is there, it will warm in longer period of time as compared to the when water is present. So if soil is dry, then it will quickly heat and as compared to the water, because if water is there, then water will trap the certain heat, and the soil, or you can say the whatever optimum temperature is needed in the crop root zone, it is not getting within short period of time if there is more water. So if proper drainage is there, means if less water is there, if soil is dry, then it will warm quickly, which is helpful particularly in the winter months. And with these, the other important function of the drainage is the better root development, and better in both, that is deeper root system as well as the more spreading. Because if water is available, then the root don't go deeper in search of the water, because if soil is dry, then only the root goes to the deeper depth and they will expand their area for absorbing the more moisture. Clear? Because if water is available, so what is the need for expanding the roots, or why the roots goes to the deeper depth if water or food is available at the surface? So if the proper aeration is there, then the root system will be strong, or they goes to the deeper depth, as well as the spreading is more. So these are the certain benefits of the drainage which will be helpful for better development of the crops. Then comes to the types of the drainage. And whatever water is drained out from the field, it can be grouped into two. One is the surface drainage, another is the subsurface drainage. If whatever water is available over the soil surface, it can be drained off. This is known as simply the surface drainage. And if water which is present in the root zone soil, it can be drained off. This is known as subsurface drainage. So this surface again having, means in surface drainage only the channels or ditches can be constructed over the surface, but in subsurface drainage either pipeline or tile lines can be embedded within the root zone or below the root zone. Means this is the open system and this is the closed system, and the pipelines or tile lines can be arranged in the soil itself. After that the covering should be done, and then crop can be grown over these ditches or you can say pipelines or tile lines, because they are embedded in the root zone. But in surface drainage system, the channels are open one, so they cannot be utilized for crop production point of view, or you can say they cause hindrance in transportation or the movement of machinery from one place to the another place, or various processes which can be necessary for crop growing. So in surface drainage system there are various subtypes. One is the natural or random. So these are the certain types of the surface drainage system. Random or natural means whatever patches are there in the field. Say for example, if field is this one, and in this field there are certain depressions. Say for example, here is the depression, here is the depression. So these depressions can be joined with the channels and they can be go to the main channel. Clear? So random system means randomly which are the low-lying areas, they can be joined together and the safe disposal of water takes place in the main ditch, and which is generally towards the slope. Clear? Means if slope is in this direction but the field is not leveled one, so whatever random patches are there which are the depressions which receive the excess water, they can be drained off with the help of the simple ditches and they can join to the main ditch. So random system is generally haphazard system, not scientific one. Then parallel drains means if suppose this is the field, if sowing is done towards this direction or if rows of the crops are in this direction, then we can make the drains parallel to the crop rows, and after that they can join into the certain sublines, and after that they can be joined to the, say for example this will join to this direction and then they can be collected to the main drain. As the name indicates, parallel drains means the parallelly we can drain out the water and after that the safe disposal takes place. In the field drain, the some more deeper trenches can be constructed within the field. Say for example, if this is the field, so the trench is constructed in the field itself, and suppose there is the main ditch and this is the sub channel. So whatever water is received, so in the field, what is the difference between this and this? They are deeper as compared to this one. The parallel one are simply used for one season only, but they can be of semi-permanent type, or you can say the channels are having the deeper depth as compared to the this one, and they can be semi-permanent, or you can say for 1 year or 2 seasons they will take. In bedding system, when the slope is very less or the field is leveled one, or you can say the slope having less than 0.5%, or you can say the field is generally leveled one. So in this case, whatever surface drainage system is adopted, only dead furrows are made. Dead furrows means suppose the crops are grown in this direction, simply one V-shape furrow is constructed with the help of either country plow or with the help of furrow opener. This is known as dead furrow, and simple the slope to the field is given, and there is no construction of the any trenches which can be obstacle for the normal functioning or normal processes of the field cultivation. So bedding system is adopted where the slope is very low or where the soil is leveled one, but the simple dead furrows or simple furrow can be opened with the help of plow, and they can be act as the drainage channel, but the more soil cannot be wasted in construction of the these kind of the channels. Then diversion drain, and interception drains are quite similar. These both kinds of the drains can be constructed against the slope. Say for example, if slope is in this direction, then the drains can be constructed at right angle to the slope direction. But in divergent drain, the whatever is the normal drainage, it can be diverted according to the passage available. But in interception drain, they can intercept the whatever is the actual slope. Means both kinds are quite similar, but in divergent drain, the normal flow can be diverted according to the farmer need. The normal drainage passage can be diverted, but in this case, the drainage channel is constructed against the slope or at right angle or at 90-degree angle to the slope direction. Suppose the slope is like this, so the drain is constructed here so that the whatever water is collected here, it can be safely moved to the another direction, and no runoff or less runoff takes place with the help of this interception drains. Then in subsurface drainage, pipe or tile drainage, mold drainage, pipe or tile drainage, mold drainage, drainage by pump or drainage well. All kinds of drainage is when there is excess moisture in the subsurface, or you can say in the root zone, then water is removed from the root zone soil. If the pipelines or tile lines is used in the draining of water, this is known as pipe or tile drainage. And the diameter of the pipe or tiles is in between 10 to 30 centimeter, or this much diameter pipeline or tile lines is used to remove the excess water within the root zone. And the layout of these pipe or tile drainage is of different kinds. Say for example, random, gridiron, herringbone. Random, just like random for surface, means where there is the depression, they can be joined with the pipeline and the water can be received through random system. Means say for example, if the depression is there, so the tile line can be embedded within the root zone at here, and they can be safe disposed of to the main drainage channel. In case of gridiron, if this is the main, means at one end of the field, the pipelines, or you can say main pipeline is constructed, and after that the water is drained with these pipeline or tile line, or you can say this is the main drainage channel and only one side of the water is collected. Means suppose depression is here, then only one side of the water can be received in the main channel, gridiron. And in herringbone, when both the sides of the water is drained in the one common channel, it has only one arm, whereas herringbone having two arms. Say for example, in the middle there is the main drainage channel and water is received from two sides, then it is known as herringbone. And if water is, suppose this is the main channel and water is received only one side, this is known as gridiron. Clear? So simply, are you able to differentiate between this and this? In this, the water is drained from one side only, and in this water is drained from both the sides. And double main means these two are helpful when the depression is in narrower passage. Means if the water is collected in the narrower zone, then only one main is there. Means either water is collected from both the side, either water is collected from only one side, only one main channel is there. But double main means if the depression area having more width, so this can collect the water from this side and this can collect the water, and this area is not cultivated one. Means two main channels are there. But in these cases only one main drainage channel is there. So double main means two main channels. In case of mole drainage, mole flow is there. Mole flow, suppose this is the seer and this is the attached with the either tractor. So this will construct the channel. Suppose this is the soil surface. Mole drainage is constructed with the help of mole plow, and mole plow place its seer within the root zone and it will construct a one hole, and after that one complete line is constructed within the root zone, and this is particularly helpful in the clay type of soils or where the sandiness is more, then chances of blockage is more. Clear? But if soil is hard enough, then whatever channel is constructed in the root zone, it cannot be closed off with the help of the silting. So this is constructed with the help of mole plow, and simple, instead of the pipe or tile line, one kacha passage is there which is constructed with the help of mole plow. The drainage pump is simply the whatever water is present in the subsurface layer, it can be pumped out with the help of pumps. Drainage by pump means pump is used by sucking the water which is present in the subsoil. And drainage well, simply construction of the well, because if well is constructed and wells doesn't have the lining, so whatever water is collected from nearby areas, it should be collected in the well, and the water from the well is further used for the irrigation purpose. So this is all about the irrigation and drainage.